Okay, let us start. So today we are going to talk about the .NET performance testing and optimization. Okay, so before I start with .NET performance testing and optimization, I would like to ask all of you: does anyone have experience testing with .NET applications?
No, sir.
So actually, one of the most complicated scripting, okay, if you compare with any of the Java applications or any other applications, if you try to record the .NET application from LoadRunner or any of the JMeter, right, you will face many difficulties while recording the script. It will have too many calls, too many web requests. It will actually load too much of. There are, I mean, it will load all the different tech stack that has been involved from the client side and server side. Most of the times when we call .NET application, majority of the times the environment that we can have is the web server is always IIS, okay, and the database server is SQL Server, Microsoft SQL Server. Like I told you last time, there is like for Java, there is something called JVM, right? To compile the code, whatever the code that we have written, that bytecode is converted into machine understandable language, and whatever the code snippets that we write, it compiled there, it performance it performs multiple checks with respect to codes, classes, methods, all the different structure that the language has. And what it will do is it will execute that executable file, and it gives us the output. Okay, but when like for .NET, like Java has JVM, the .NET have something called CLR, okay, the common language runtime, which executes the executables. But the only advantage of .NET is you can write a script in multiple languages. You can write, let me show it to you. You can write VB, you can write C++, you can write in C Sharp. JavaScript is a different thing, and you have some environment where you can write all of them and you can integrate it to some profiling tools. Okay, so testing is a different part. For when you test it, you record some scripts, you execute it, and you have separate metrics and monitors for all of them to monitor how the application is behaving under load. And you can simply see what are all the different metrics with respect to the thresholds that you set when you have some user load with 2000 users or 3000 users, depending upon the complexity of architecture that you have, and accordingly you report all the issues. And what you have to remember here is you will not be able to understand anything from the .NET coding side, and you will not be allowed to touch anything, or you cannot manipulate anything from the code that has been already written. Our job or our role, importantly, what we do here is only we test, we see the performance degradations, and we report them accordingly. For example, you must be having a, I don't know how many of you have tried this one. This is one of the uh, profiling tool for .NET based applications. Any profiling tool, like for Java, you have EverKit Java profiler, you have App Perfect Java profiler, you have JProfiler, JProbe, and you have many other profilers to profile your code and to see the utilizations of memory, processor, and to check what each thread is doing, how much each thread is, how much time each thread is executing, and you can track the real-time data. You can collect various statistics of all the applications. Okay, it can be Java by using Java profilers, using a process ID. You can go there, you can take the sampling, or you, with the help of the performance counters, you can collect so much of data for all the duration where the test execution happened. And you can profile any app, like you can profile an app which is running on a VM. You can connect to that app remotely, or you can connect to any of the local app, or you can connect to any of the running app. So you must be you must have installed something called LoadRunner, right? All of you must have installed LoadRunner on your local machines. So if you see the installation part, there is something called .NET Framework, right? So I kept this open. I have opened this LoadRunner Vision. This is an app which is running with .NET Framework. So what you can do is you can just attach a running app. You can create some sampling. Okay, you can take a metric called thread time, and you can use a profiler API. I'm selecting a Vision here. Okay, you can just simply click on run. So what it will do is it will open the profiler. It will capture all the statistics of what exactly happened with that process ID of that particular .NET based application, and it will tell you what is the metrics that you have. Like if you see, there is something called memory, there is a CPU, there is no real time data that is shown here. But what you can do is there is an application from GitHub. I don't know how many of you know how to download an application from GitHub and how to bring that or integrate that to your environment that you have. You can integrate this dot trace profiler with your Visual Studio, and you can also bring all of that sample application here, or you can also track. Just a minute. For now, it is not generating any data, but once you stop this one,
Sir, one question.
yes,
Yeah. So this basically this dot trace home, this tracks out all the runtime details for .NET based application, correct?
right.
Yeah. And the load run that you have actually integrated with this, it is running on a .NET application, and that's why it is actually started as a profiling tool for, and started tracing the details like memory, CPU for that .NET based application, where scripts are running from load runner. Am I correct?
Right. No, no, I haven't. Okay, so there's a lot of background noise. So what I'm trying to tell you here is I am trying to profile an application which is running in .NET. Even if you take the LoadRunner instance, right, whatever you have installed the LoadRunner Vision controller and analysis, to run all of them, we need .NET framework, and this .NET framework is already installed as a prerequisite when you try to install this LoadRunner. If you want to check the performance of your application, there is a situation where we have tested all the HP applications. We have already tested, we have already done performance testing some 5 to 6 years back on HP Quality Center and HP some other tools, OpenU, Service Manager, and all. When we tested all of them, those are all .NET based tools actually. For all of them to run, when you try to run all these tools, or when you try to install all of them, you need the .NET framework. Whichever tool or whichever is application is running on a .NET framework, or whichever application is already developed on .NET, you can directly go and profile that particular app. When your load test is happening on that .NET based application, you can go to the tab, you can connect to the tab, you can also connect to that directly to the .NET Core application, or the IIS web server, or WCF service. We have many of the components and different tech stack that has been involved in a .NET developed application. So you can connect to any of the type, the tech stack type, and you can start profiling. So what it will tell you is, uh, is this one? Closed it. Okay, let us go with this one.
Collection is happening. Okay, this garbage collection is happening, right? Which means that in processor.
Cancel it. There is an application, a sample.NET based application in GitHub. I'll share you the link. So there are various steps on how to create or how to integrate the sample application to your local environment. You need not do anything. Whatever the code that you have in the sample application, you can open that in the Visual Studio and you can integrate. It is already, that application is already integrated with the .trace profiler of this .NET instance. What you can do is, once you have that application installed with that environment, there are some 8 to 10 steps on how to create that environment and how to create that application with Visual Studio. And the installation, the integration from .trace to that Visual Studio is very, very simple, and the integration comes by default. So what you can do is, you can just run this profiler. That is it. Let me open my cloud machine. I don't. And mostly in another 1 or 2 days, I'll be giving you 2 machines on slot basis where I have this Oracle database installed. Okay, you can directly go to this machine. Yesterday I have installed this Oracle 12c server. There are few scripts, you can run them and you can generate AWR report, ASH report and ATDM report. Okay, you can go and practice, or you can get some good hands-on experience with respect to all the database activities from here. You see this top sessions, PG advisor, memory settings, everything. You can go here. I have installed. I'll share you the machine details with Kumar sir, Anita ma'am will share it to you. You can go here. I'll share you the path of the scripts where I have uploaded. You can go there and you can start practicing. In the same way, I have already given this J profiler, your kit profiler, and app perfect. I'll give you this dot trace profiler, and there is another profiler called your kit profiler for .NET. Your kit profiler will work for both the .NET and Java, but the installation is file is different for .NET and Java. So let us stop and see if it is giving any data.
Who's that? Oh, that's Helena Ravenclaw. Rowena Ravenclaw's daughter. But she prefers being called Raven because she's always been in her mom's shadow. And she hit the diagram of Ravenclaw.
It is not.
Bloody Mary killed her, of course. And then he realized what he'd done and he killed himself.
Okay. So I'll share these slides as well, but do not share this PPT with anyone because this is an TCS confidential one. Okay, and if you go back and see what are all the different bottlenecks that you see in, performance .NET performance testing, database bottlenecks. The first thing every time you see in any of the Java application, the first question that comes.
We are losing your voice, RK. We are not able to hear.
No, I am getting a lot of disturbance. Can all of you place your call on mute?
You're gonna break the barrier. That curve. So it goes up and then goes down.
Okay, it's better now. What are the times when you, is it better now? Is my voice better now?
It's still breaking in between, actually.
Hello?
Yes, RK.
Is it better now?
Yeah, it's better. Thank you.
Thanks. So, see, if you take any application, it can be Java or it can be .NET. The first thing that you see is a high response time. Okay, the most common and regular complaint about any website or any web application is like I'm seeing an high response times, or it is always being said that the web page is very slow. And if you go to the second part, we always worry about something like CPU utilization, memory utilization, and etc. etc. So when we see, forget about Java first. We will talk about only .NET. When we see, when we say any URL or any application is slow, the first thing that comes to our mind is from which place we need to start our investigation. Okay, and as I told you many of the times, is it slow for one user or is it happening for all the user roles, for all the users? And you may have, when we do any of the performance investigations, we may have a lot of different questions to fix the issue, and it is not you or me again who is fixing the issue. It is an ASP.NET developer who can fix it. That is what he can do. Even if you use dot trace profiler or ants profiler or CLR profiler to check the efficiency of the code, we will not be able to touch anything from the source code. You need to keep this in mind. But one thing that you can do is whatever we have in this PPT, it is completely highlighted only about the performance degradations and performance best practices, and it is talking about all the different components and metrics what and all that we have to monitor when we are doing .NET performance testing. Okay, so there is, like in Java JVM, you also have Git compiler in the CLR. If you talk about the last part, if you see, this is common language runtime. It will take all the files. It will go. It will make necessary checks. This is the framework that is being used. If you talk about all these things, you may not understand what it will do, but at a high level, the framework will take as input whatever the language that you write. It will take all the files as an input, like in JVM, it will the binary, the class libraries will do the security check, or it will do the threading allocation, it will do the memory allocation. Like in JVM, you also have something called garbage collector in CLR, and you also have heap, and you also have generations in the heap that you have in CLR. You will not have so many Eden space, younger generation, older generation, meta space, survivor 0, survivor 1, where they're together called survivor space. You will only have three generations, that is called Gen 0, Gen 1, and Gen 2. Okay, Gen 0 is a very little portion of the total heap, and generation 1 is some bigger portion, some 30 to 40 percentage of the memory allocation, and Zen 2 is it will be the more amount of memory will be allocated to generation 2 in the CLR heap. The reason is because the long lived objects will be promoted there and they lives there. It works same like JVM, but you will not have so many memory allocations. You will have only three memory allocations. One is generation 0, generation 1, and generation 2. And there is a garbage collector. You will not have so many garbage collections like minor, major, full GC, all. I mean, like we have in JVM, we'll have one GC. Every time that kicks in, that comes in, whenever the objects are full, it comes in, it will reclaim the memory, and it will remove all the unreferenced objects which are no longer being used or referenced. So we'll talk about all of them, and there is, we always need to worry about the most of the time that has been that has been spent in Git compiler, uh, and majority of the times you always have issues with view state. Anyone of you know what is view state?
It's a .NET, ASP.NET state management mechanism.
What is that view state?
It's we can see that in our load runner script when we record for ASP.NET application. It's like a main session management variable used for maintaining the state of the pages when we navigate from one page to another page.
Right. Even if you see, I don't know how many of you have worked on these .NET based applications, you will be correlating two unique values when you performance test or when you work with .NET based applications. One is view state. If you don't correlate that value, you will not be able to, you cannot pass the script. The script will always fail. Okay. And if you take this view state value for any of the BFSC application, the view state value can be hundreds of lines. I have seen some view states which are of 200 lines or 300 lines. So do you capture all the value from that view? Do you capture all the view state value which is of 200 lines, 300 lines, and then try to find out in the response file? You cannot do that, right? So even when you correlate it, when you have a large view state with 200 lines, you will be copying some 2 lines of that view state value randomly, and then you try to find it. That is how we used to correlate it. So most of the times, having larger view states is always a problem. When you have a larger view state, okay, the page rendering and the loading of all the elements in a page and the response time of that application will have a very high impact. So most of the people, they don't enable this view state. Instead of having a large view state, they will have a very small view state. And if they think, the development team came to a conclusion that the view state is no longer required for our load testing, then we can enable this view state. Even yesterday, when I tried to download one of the application, sample application, I downloaded a file called web.config. Whatever the changes that you do in a .NET application, you do all the changes in web.config file. I'll tell you what changes you will do in this config file. Okay. If you want to enable view state, or if you want to disable view state, you will go to this web.config file of any .NET based application, and you will change the you will make the necessary changes. And if you take any of the .NET based applications, 50%, 60% of the issues that you always see are the database bottlenecks. Okay. And in any of the load balanced infrastructure where you have too many transactions, when your load is continuously increasing, and you can add more and more number of web servers to scale linearly, but you cannot add more database servers. That is the problem. For example, what is the ideal utilization that you can have on a database server? You are running a load test. What is the when do you come to a conclusion that, okay, this is working as expected? What is the utilization? What are the good numbers that you can think of in terms of database utilization? It is 20 to 30%, or 30 to 50%, or 50 to 70%. Any idea?
50 to 60%.
Anyone?
It shouldn't go more than 80%.
See, if you, I mean, let us go a little bit. I'll go back to some basics. Do you know what is time to first byte?
Time to first byte is like from the time when the request is made from client, and it reaches the server. At server side, it gets processed, and then it is the response is sent over the network, and the time the first byte is received. This entire time is TTFB, time to first byte.
Okay, so let me talk about few problems here. We are talking only about .NET. Forget about the remaining issues. So the first problem is always a slowness. It can be from the response time. It can be from anything. It can be loading of a web page, or it can be some HTTP 5XX 5XX error. So in case the reason why you get many of the 500 errors are because of you will have too many timeouts. Okay, and the load balancer may not handle the request for a prolonged period of time. You got nothing to do with .NET troubleshooting here. If you have too much of load on your application, and if your load balancer is not able to handle the concurrency of your application with the algorithm that you have selected, if the timeout, you will see many of the timeout errors. Okay, and to identify this timeout error, you need some data. You need to collect some statistics from which place for which request the timeout happened. For that, you need to have some basic to advanced metrics. Even on the load balancer, you need to monitor the load balancer, and you need to tell why this timeout has happened. And to identify many of the performance issues from .NET based applications with respect to possible causes of our slowness in any .NET application, the main reason is it can be because of slow JavaScript. That is why the reason uh, there is a new concept, client-side performance testing has been separated from .NET based applications. If you take any of the .NET based application, it will also consider the client side, the server side, or anything that is there in between the client and server. Okay, most of the issues that you see with the slow JavaScripts, the HD images, the rendering, I told you, right, a large view state. When you have a larger view state, to read all the view state, it will wait for a prolonged period of time, and if you will see a timeout error. And if you have a high view state, to read all of that, to understand the request and give a response from the server in a .NET based application, you see a lot of rendering time and you'll see a lot of asset loading. That means that it will take a lot of too much of download time or too much of rendering time to download all the assets that you have in a web page. And there are different issues from the DNS. Sometimes it will not be able to identify the respective IP. It is like a telephone book, right? It has to identify the respective domain using something called IP address, and it has to bring the response from that respective domain name server. So sometimes even it fails to identify the domain name server, and it will throw you an exception or a timeout. And you can also see the ISP issues, internet service provider issues. You can see the network issue. You can also face some intermittent issues from switches, routers, load balancers, and most importantly, the application code. Okay, you will not be a part of any of the code reviews, but when you try to profile to understand the overhead with respect to CPU, memory, disk, network, everything, you need to use a profiling tool like this to scan your application code, to profile your application code, and you can find out many of the metrics like how much each thread is taking, how much time each thread is executing, how the thread cycle is working, and how many different threads are blocked or it has deadlocks. You can see all of them there. And you can also look at some third-party services. Third-party services can be many in .NET based applications. Even you have third-party services in Java based applications. Okay, and the last part is the SQL server. Again, when I say the SQL server, depending upon the complexity of your code, the infrastructure, uh, you will see a lot many SQL server issues, especially with the stored procedures and SQL queries, long running queries. And to drill down or to optimize all of them, you need to use a SQL profiler uh, for all the queries, and accordingly you need to understand which one is a slow request. And you again, I told you in the Oracle, right, you have an optimizer which is a heart of SQL processing engine. It internally optimizes the performance of a SQL query, but there is some manual intervention required to take care of a query, and we need to ensure that that query is not taking too much of time. If a particular query is taking too much of time, then it will definitely impact the performance. As I told you, uh, for every transaction, we call it as a transaction in performance testing. uh, for every transaction you log in, you click on something, you open a record, you search something, you book something, you make a payment. Every transaction is a query. Okay, and many transactions are done by n number of users geographically, and each time a user is accessing the application or making some transaction, every time a query is executed, you will have lakhs of queries which will be executed millions of times in a 24 hours time frame. So if any of the single query, okay, which is a high priority transaction, is taking too much of time, that will be a very big bottleneck, and there is a lot of possibility of showing a very negative impact on other existing functionalities which are already working fine. If some transaction is showing you some excess delay, or it is giving you some high response time, it means that it is also stopping other resources, or it is also giving some negative impact on other existing transactions which are already working fine. So in that case, you need to look at all these metrics, and when you start your investigations, you need to use some performance profilers or SQL query execution plans. The reason why I'm telling you repeatedly about SQL queries and storage procedures is because, for example, let me write here. You have a web request, okay? You have a web request which is taking 100 milliseconds. 100 milliseconds is nothing but 0.1 second, right? So, and you have a SQL query, sorry, which is taking 5 seconds. Okay, if you try to calculate the total processing time, let's say that response time, the total time taken for a web request and the total time that has been taken to execute and to run this SQL query is 5.1 seconds. If I'm trying to optimize, if I'm giving a overall improvement on my response time, which is 5.1 seconds, let's say that I have minimized this particular parameter. Now my web request is not taking 0.1 seconds, instead it is taking only 0 seconds. Now the total processing time, the overall marginal improvement that came from 5.1 seconds to 5 seconds. Okay, this improvement will not help me in any of the ways, right? Instead of directly troubleshooting the web request processing time, which is 100 milliseconds, it will not give you a very big value add in to your response times. If you look at any of the SQL query, the most uh, time consuming or a resource utilized thing is only the SQL query or the store procedure that you have inside the database. The first primary thing every time that you need to do is, if you want to investigate or if you want to troubleshoot anything from the performance side, the first thing that you have to start with the database. If you go to the database, forget about the execution plan, schema thing, and other stuff. You need to look at how much each SQL query is taking. If you are optimizing the SQL query, which is taking 5 seconds to 2.9 seconds, or 3 seconds, now the overall time would be 2.9 seconds, which is an industry standard, or 3.01 seconds. Instead of, instead of troubleshooting or instead of optimizing this particular web request, talking to a developer, asking him to optimize this value, you can directly go back to the SQL query. You can identify which is a long running query, then you can optimize that, which when you optimize the SQL query, it will improve the overall it will bring a overall marginal improvement in terms of response time. Okay, you will have a lot of potential gain when you try to minimize something from 9 seconds to 5 seconds or 5 seconds to 3 seconds. Okay, even if we talk about some basics, when we talk about uh, any investigation from the .NET side, the first parameter we always see, if you have a high response time, we always see the time to first byte. Okay, basically what it tells is it will tell you the total time that it has taken for a server to give the time to first byte information. Typically you will see the response of a particular request in a web browser. The first thing that you see is nothing but the first thing that you see in a response for for a request that you have sent. What you see in a web browser is nothing but time to first byte. This time to first byte will include mm, like the socket connection time or the total time that has been taken to send the HTTP request, and the time that has been taken to get the first byte of the page, some kind of loading in the browser. Okay, so this is one of the primary metric to use. Time to first byte is very important to determine how responsive your site is or your application is. Okay, if your time to first byte value is very large, what does it mean? Anyone? You are saying
The,
to
the
yes.
server side and the network side has taken more time. If TTFB is more, that's the interpretation.
That's what. If you see high response times, we did not do any profiling. The first investigation we started. If you see high response times, the first metric that you see is TTFB. This is the most. This is the first primary metric to monitor. The reason is because it is telling you whether the socket connection has happened or not. It will tell you the socket connection time. It will tell you whether the HTTP request has been sent and the time that has been taken for the HTTP request, and also the time that has been taken to get the first byte. You will get some kind of response in the response file. This all includes in time to first byte. Okay, for example, when I'm monitoring this metric, this should be very low relatively. Okay, if I'm seeing some large value in TTFB, it means that there is no activity in the browser. Okay, and it means that nothing is happening or no information is being received from the server, and the browser is not able to display anything, any content. So when someone is asking you what is the first investigation that you see, when you see a high response times, you can immediately tell them that I see time to first byte, because time to first byte will give me the all information about the socket connection time or the time taken for sending my HTTP request and the time taken to get the first byte of my page. Okay, and when you go back and see the total page response time, this metric will not only include the TTFB time, okay, it will also include the complete time of all the aspects of a web application, which includes the images loading, the JavaScript files loading, and this cascading style sheets, the CSS files. So when I say response time, it includes all of them: TTFP, loading of all the relevant stack, the HTTP, the time taken for socket connection time, the HTTP request time, the HTTP response time. It takes all of them. Now that is total response time. Now what about average response time? This is another important metric and a misleading metric. What do you mean by average response time? What does that actually mean? Does it refer to average time to first byte or average total page response time, or does it include static resources such as CSS or image files?
Average response time from load runner side you're asking, is it?
No, for the entire application. Because average is calculated for all the users that are accessing the application, right? If I take an average response time overall on my application, it is talking about all the transactions and all the users who are accessing it globally. I'm
Yes.
looking at average response time. If I take the maximum can be up to 128 seconds. I am not considering it. It can happen from any of the country, from the globe. It can happen from Ukraine for one user because of his data center can be down, or his server can be down, or his ISP is bad, router is bad. Can be of many reasons. But when I look at my application performance, I worry about something called average response time. What does an average response time mean?
Average response time includes the time to loss buffer, right? TTLB.
Okay.
Because the client sent a request and it has been processed and it has been sent over the network, and till the last byte is received at the client side, that is considered as an average response time.
Let us say that, let us put the question this way. I have an application. Now my application is slow. My .NET application is slow. And it can have a number of reasons. It can be because of slow JavaScript, slow rendering. I have some DNS issues, ISP issues, or I have some issue with the application code. So some load balancer issues, web server issues. There can be many of the reasons. Now I'm straight away looking at my TTFB, then my total response times. Then now I'm looking at my average response time. What is that I understand from my average response time now? To go ahead with the remaining investigations on my .NET slowness, .NET application slowness, what does that I understand from my average response time?
Sorry, RK, like when you say average response time, from where we are seeing this average response time? In the browser?
You can say you can say that it can be in load runner.
Okay. So yeah, if it is in load runner, yeah, this TTLB is what we consider as an average response time, because in load runner we don't calculate the once all the bytes have been received, we don't calculate the way it renders, because we care only about the time till we receive the last buffer. That is what average response time from load runner side.
Mhm.
Probably from a very high level perspective, I can say that average response time can be very, very misleading because it average out all the requests with its responses. So sometimes if the requests are, the responses are way too higher, but few of the responses are way too low because of any issues, that again get negated and it doesn't portray the right picture all time. And the vice versa is also true. So instead of, I don't know, probably for higher level views, I think we should be considering percentile value rather than an average response time.
So perfect. So if you remember, there is something called 90th percentile, which was used to determine the average response time, right? Do you
Yeah.
remember what is 90th percentile?
Yeah. Yes.
So it was basically ordered from best to worst times.
Yeah.
The last percentage, the requests in the last 10% of the requests are the 10 worst performing requests. If you take the 90th percentile. So that is how you find the average. So basically, the reason why you take the average response time is to compare the previous averages of the same time period. If you have a similar test which has been already ran, okay, the latest performance run, the average response times you take and you try to compare with the last run to show some improvement or to compare the degradation. Okay, so basically the average response times will include all most of the TTFP or the complete total page response times discussed just now, right? So you can set any of the percentile value to see to what percentage of the requests or to what percentage of the transactions are behaving better, okay, in terms of both time to first byte and total page response time. This is how the average is calculated. If you have any issue with the TTFP or total page response time, then there is a different investigation. Again, you need to go back and see what is happening with this one. And after looking at all the metrics, you need to understand to investigate further what are all the other metrics from basic to advanced that we really need, okay, to check the degradation of our .NET application. For example, if you take high CPU utilization, what does it mean? You can say that whatever the tasks that are performing from the application side, those are happening inefficiently, okay, and it is saying that it is having some excessive processor utilization which can lead to some higher CPU utilization. You can have multiple processors in it, and there can be one processor. If you have four processors in a CPU, and there is one processor which is having some aggressive behavior, which is continuously taking your CPU utilization to 90%. So for that, you cannot directly take a simple conclusion by adding one more processor to it, or you cannot directly say that this is happening because of this particular incident or because of this particular web request. No, you cannot say that. So, and even the same thing with the the high memory utilization. High memory utilizations, uh, it means that the resources are not being utilized appropriately. It is a simple thing, but you cannot say a lot of memory is required to handle all of the objects that you have inside the CLR, and releasing and there can be many issues by CLR not releasing the memory for every object which is no longer being referenced, or memory which is not being managed efficiently. So there could be n number of reasons for high CPU and high memory utilizations, and any high indicator with respect to both CPU and memory, okay, they are indirectly saying that there is some inefficient usage of your objects, or inefficient uh, resource usage or memory usage, inefficient memory management or hardware management. They can give you some indirect hints, but again, those are not the direct statements saying that these high indicators are happening because of this scenario. Okay, for example, system performance will directly get impacted by something called CPU and memory utilization. If your CPU and memory utilizations are increasing, the response times will increase. You don't know, you're not completely sure why the response times are increasing, and to investigate why CPU and memory are increasing, then you have to go to that particular server where your application is installed. If it is an Windows server, you need to add some metrics by using perf1, or if it is an Linux server, you need to use nmon utility to see what is happening. Okay, so here if you look at the framework, there are let's say that if someone is asking you what are all the design considerations and browser considerations that you have done from your side, you, even if you say that efficient exception management, no one from the performance testing or engineering side knows what is an efficient exception management from the .NET. It is not really necessary to know all of these areas, but there are some .NET performance design considerations which are applicable to the .NET developers, development teams. Okay, efficient resource management. What is efficient resource management? It is saying that all the resources or all the objects that you write as a part of your code, it has to make use of the resources efficiently. It means that it has to make use of the memory in an efficient manner. It should not give me any memory leaks, or it should allocate the memory accordingly. If you remember, I told you the concept called nullifying the reference variables, right? Do you remember?
Yes.
The nullifying reference variables is nothing but you have different references: phantom reference, strong reference, weak reference from the development concepts. So if an object is survived for a minimum of some minor GC cycles, it gets promoted. Okay, if it is surviving more number of cycles than the previous memory section, it will be promoted to the for example, if you have generation 0, it is saying this is the place where the objects are created. It is the short-lived objects are lived here. Generation 0. Okay, generation 1 is basically the objects which are promoted, which has survived some minimum number of GC cycles in generation 0, they get promoted to generation 1, and this is collected less frequently than generation 0. And whichever the objects are survived from many, after many cycles of minor GCs or something, which are called long-lived objects, they promoted to generation 2. But there are few references which are already there in generation 0. They are not getting deleted by something called garbage collector. So when he is saying that efficient resource management, he has to write a code in a way that all the objects are not creating any of the deadlocks, or not creating any of the locks. When they are, when he is not designing the code in a way where efficient resource management is not happening, it will lead to memory leaks, it will lead to the deadlocks, you will have blocked threads, you will have waiting threads. When you have blocked threads and waiting threads, that is the solution for high response times. If someone is asking you what is the reason for high response time, you have so many waiting threads. Why are the threads waiting? The design of the code is not appropriate. I told you, right? If you remember one important point, if there is a deadlock, can we directly eliminate a deadlock? Can I directly go and delete that thread? Can I do that?
No.
No, we can't.
What is the solution for that? If you have a deadlock,
The coding has to be redesigned so that the threads doesn't get locked, and the resources doesn't get utilized and blocked by a certain thread.
right? There is no straight there is no straight point to eliminate the bottleneck directly. We cannot directly delete that particular thread. You have to take a snap of it. You have to go back to a developer and say that first, there are too many deadlocks happening. Because of these deadlocks, the other threads are not able to utilize the resources which are being locked. Okay, so what you can ask him is, please write your code or refactor your code in a way where deadlocks will not happen. That is the only solution. If the developer is writing a code, develop the deadlocks should never happen. If you have a deadlock, you will have a high response time. If you have a deadlock, you will be seeing some HTTP errors. You will see the HTTP errors. The reason is because it will throw you some exceptions, because the response is not being served for a particular request, right? You will see a lot of timeout errors. That is one reason for high response times. And these are the three different memory areas that you have, and you obviously see the GC performance, and you need to check how frequently the GC is happening. I will install a sample .NET application and I'll give you the .trace profiler. And if when you run a sample code snippet, it will create some dummy load, and you can see the GC utilization, you can see the memory utilization, and you can also see whether the memory leak is happening or not. So you will see the graph in a sawtooth pattern. That means that memory is allocated and deallocated. That is how the graph should look like, right? If you see a sawtooth pattern in your heap graph, it means that the memory is getting allocated and getting deallocated. It means that it is freeing up the memory. The garbage collector is coming in and it is freeing up the memory for all the objects which are no longer required. Okay. So these are all the considerations, and most importantly, after using the .trace profiler to see the application profiling, the code level profiling, you need to go back and see the web server tuning. Okay, the web server tuning is nothing but every time you will use only the IIS server as a web server in .NET based applications. You must have seen no infrastructure or no .NET application will use any other web server other than IIS, right? And most of the .NET performance issues and other scalability issues in common that you see are the memory misuse. Most of like in Java, it will create too many objects and it will fail to release the resources, which can lead to increased working set. I'll tell you what is working set. When the working set, see, there is one direct bottleneck that you can explain in your interview. Okay, that is nothing but, for example, I have too many objects that are created. Can you tell me what is the next step? The object has to be removed if the job is done, right? That is the next step. Hello?
Yeah, we can hear you.
Okay. So there will be too many objects that are created. Okay. And most of the times what will happen is the objects are still being referenced. Okay. Even after the work is completed of that particular object, the reference is still there, and that is why the reason this object is not freed up from the memory. So most of the times .NET applications will have a lot of memory misusage because it will fail to release all the resources, all the objects, and it will reduce the performance of your application. Okay, there is another thing called resource cleanup. Resource cleanup is nothing but there is a concept of finalizers. Okay, when something is not really needed, the developer has to use some dispose method in the finalization, and he has to release all the unused objects and resources from the memory. If he's not doing it, if he's not cleaning all the resources, or if he's not doing any of this resource cleanup, the .NET developer, it will have some excess usage on the resources. It will have some unmanaged uh, unmanaged objects, and all these unmanaged objects will create too many blocked threads, or it will have some deadlocks, and it will give you some high resource, I mean, for example, a memory leak. Most of the times you can see the memory leaks. Okay, and you always see, like in Java, you you cannot take being a performance engineer, you cannot directly take a complete complete control on how the threads are being managed, and creating threads is not in our bucket. So the developer will think of on which priority, or how the threads has to share the resources, or which thread has to use which thread pool, and depending upon his choice he will allocate all these threads to the respective thread pools, and how the threads has to run in a thread life cycle. So you see various bottlenecks from the server side because of this threading issues, and you have to monitor all of them only by using a proper APM tool what is happening to these threads. And whatever the different abnormalities that you see from the threads concepts, you need to go back to the developer and you have to confirm for 3 to 4 times why it is happening with this particular thread by using a thread ID, which is always unique. Okay, so and there are various metrics. Okay, you can go back and see this is an IAS architecture. This is not really required. If anyone of you have some good experience in IAS, you can go back and see, go through all this uh, IAS architecture and what you can do with this IAS. Okay, these are all the most important metrics that you have to monitor. And if you see the thresholds here, these are all the limit, the thresholds that you have to observe for .NET based applications. From IAS performance server, IAS web server, the web service or the current connections, and it is giving you giving you the suggested threshold, and it is also explaining you what each metric is doing. Okay, and I forgot to tell you one thing. I forgot to tell you one the okay, when I say the CPU utilization, right? CPU utilization, I explained you CPU utilization, right? For example, yeah, if I'm trying to monitor, I'm getting high response times in my .NET application. Now I also identified that there is a high CPU. Basically, the usage of my CPU should remain low, right? That is how my performance is good. That is how I can measure my performance, or how I consider my performance seems to be good. So if I take my database server, if I'm trying to measure my database CPU, an average of 20 to 30% is generally acceptable. Okay, or even 40-45% is also acceptable on my database. Anything over this could indicate my database server will begin to be overloaded, or it it can be slow. It can exhibit, or it can start showing some kind of slowness. The reason is because the SQL queries are getting executed, or it can be because of the execution plan, or it can be because of some schema changes or some initialization parameter settings. You can do all of them here. So an average CPU utilization 20 to 30% even on my web or application server is fine. If I'm going back and I'm seeing my web server or an application server, if I'm seeing 20 to 45% utilization, CPU utilization is excellent. 20 to 30% indicates excellent, and anything above that, for example, if you take 40-45%, it is some kind of a hint. It can give you, and it can start giving you some kind of slowness. When you see 40 above 45, it means that now from now on you will start seeing the degradations. It is an indication like that. Or if you see any of the 50 to 70% in an application server, you can say that it is an well utilization, it is an well utilized system compute I'm sorry, if you see any application server under 20 to 30%, it means that it is being utilized good with an excellent condition. Anything above 50, it is 50 to 60, you can say it is an well utilized system. But if you are seeing anything above 70% in any of the web farm, it can be web server or an app server, it means that it has been reached its computational capacity. That means that with respect to the hardware of your web server or app server, if it is above 70%, it means that it is running out of the resources. That is one point. The second point, you cannot directly jump onto that statement. You are seeing this well.
RK, one
Yes,
question, RK.
yes, sir.
Is this like a resource utilization you're telling for a steady state, or does that include the ramp up and ramp down?
Everything.
Includes ramp up and ramp down. Okay.
Yes,
Okay.
yes. So no, see, when you say the ramp up, when you publish a result, just to give, because when you run with high number of users, you will have a very longer ramp up and longer ramp down, right? If you are trying to run with load test with 4,000 to 5,000 users, you cannot increase all of them. You cannot bring all of them in one go. You for to bring all of these users in ramp up, it will take a minimum of 15 to 30 minutes. But when you publish the result, you take the average only on the steady state. But when we talk
Okay.
about any of the utilizations, it is talking about a single user that is there on the application. Any user that is accessing the application, it is calculating. It can be with one user or it can be with thousands of users. Okay, so adding a web server or application server is very simple. Horizontal scaling or vertical scaling with respect to the server garden, you can add web server and app server then and there, but adding a database server is very difficult. Okay, so for that reason, you need to see to what percentage of the utilization is being there in your web app DB servers. Okay, so these are all the different metrics. You can look at all of them. And
Okay, I have a question.
yes, sir.
Yeah. So when you say that horizontal or vertical scaling is easy for app server, but it's difficult for DB server. Can you please repeat that? Why it is difficult for DB server to, expand?
No, because DB server, it has too many things to do from the DB side. But when you have you heard about something called Red Hat OpenShift?
Yes, I heard about it.
Most of the things can be managed by node level or pod level. All the services or all the different things that are running from the web and app can be managed by a service and a pod. You can simply bring that down and you can make some necessary changes and you can bring that up. But it is not the thing with database has too many things to take care of, like the data or the different tables that the application is accessing, or the data access path that which has to be defined before an application hits the database server. So when you send a request, it has to fetch some data, right? So you have to define from which table, from which instance, or from which SID of the database it has to bring all this data. So when you decide a database, especially in testing environments, it will be very hard for us to establish another database with all different configurations, and it will be very difficult for us to have a distributed kind of hitting when you have two databases in place. So that is one difficulty. But whereas in web server and app server, it is not that. It is not the. It is not that case. It is it is like creating another cluster or another node, or creating another instance. It would be much more easier when you compare it with database. Again, for database, the reason why it is very much difficult is because it depends on many parameters, like what type of schema or what type of uh, again, there are too many different techniques with respect to partitioning, schemas, execution plans, the tables, the data access paths, everything will change. So you need to configure again all of them to the application, to your environment. Then again, you have to start your testing.
Agreed. But one more side, I'm not sure, but most of the cases for larger systems, we don't only operate with single DB, right? We do operate with multiple DBs there also, and the and table and schema structure, and it basically the DB is distributed there as well, right? So
That actually depends upon how much volume of data that you're testing. So if you have 3 lakhs of records for 1 hour, you will not, one database will not be sufficient for your load testing. But for all our staging, I mean, which is 1/4 of our production need, production capacity, you will not, if it is Oracle, you will not need more than one database, because my Oracle database is now having 128 CPUs with 512 GB RAM. That is a test environment which can accommodate up to 2 lakh users. You cannot really work with 2 lakh users in a test environment. Even I don't, we will not, no client will be able to buy 2 lakh users license first of all. So you really know, you, I mean, but again, when you talk about the production instances, you will definitely have too many databases. For example, the current client which I'm working, BMW, is having 18 databases, 18 Oracle databases in production, which is supporting some 130 plus applications. So the production is completely different. But when you compare, when we talk about the testing environment, it is a single environment which is so-called three-tier architecture. If it is not Dockerized, or if it is not an SaaS instance, or if it is purely an on-premise instance, you will have a one single three-tier architecture where you will be doing all these end-to-end activities in one single place. And again, it depends on the complexity of your scenarios on what you are testing. It is not always that we can have only one Oracle database server, but Oracle database server, it is now, any of the VMware vendors are giving one single server with high configuration. You can, if you want, you can also break that server into bits and pieces, like 128 CPUs each of them, and you can make 3 Oracle database servers. But when coming to the test environment setup, you will face a lot many challenges. You need to distribute the load accordingly. You need to take care of all the, you need to have this load balance algorithm where it has to distribute the load equally to all the database instances that you have, and you need to upload all the data in all the 3 databases. And there are other challenges actually. If one of the database is not being used, you have to identify that issues and all. Okay, so this was the path that I'm talking about. You can directly go to this Windows server. You can access this machine config files. Okay, this is where you can set the maximum number of connections, or the minimum, the working threads, or the number of CPUs. You can give all the required thread settings into this machine.config file. Okay, you must, if you remember, I, I showed you, right, where to set this heap settings and all. I did not show you. So this is a file called 1 minute. 1 minute. Middleware Oracle Home. User projects, domains, base domain, bin. Did you see this set domain environment variables? Did you see this file? So to increase, this is the file that I opened. To increase the heap, to set the minimum and maximum heap size, this is the file that you need to access, and this is where you have to give the minimum and maximum heap size. This is your lab machine actually. This is the lab that I have created for you. This is where I have uh, deployed the application that I have told you in the WebLogic server. Okay, so I'll tell you where you have to give these values. Shit. Okay, these are the values that you need to set actually. If you want to set the XMS and XMX for a 64-bit machine, you need to set this value. If I can give 512 and I can also give 1024. This is where you need to set your heap value. Okay, and this is the application that I have selected, that I have given it to you, the war file that you have to deploy on your WebLogic server. So this is the application. Once you go to this war file, there is a file called IAQ properties. Okay, once you deploy this application into the WebLogic 12c generic installer, you can you can connect this application with any of the database. If you see here, you can connect this application from WebLogic to MySQL. Okay, you can connect to Oracle, you can connect to MS SQL, you can connect to IBM DB2. These these parameters are commented. You need to uncomment here, and you need to give the URL of this JDBC driver, username and password with port and SAT of the Oracle instance, and you need to give the data source URL. Okay, you need to give all the details. When you give all these details, right, what will happen? The application, that the war file that you deployed on this WebLogic will get connected to the Oracle database, which is already installed on the other machine. Got it? So this kind of configurations will be very difficult when you have multiple databases with one single application. With one application which is having only one web tier or one app tier, it will be hard for you to do some configurations to multiple databases. Even if you do all these configurations, when you have multiple databases, you need to ensure that all the load is being distributed equally, and the right data is being fetched for all the requests that an application is sending. That is Again, that is another task to monitor, to keep an eye and to monitor all the metrics from the two databases. You have to monitor both the databases simultaneously, right? And this is like in WebLogic for .NET application, you have a file called machine.config. This is where you can directly set all your threading configurations. You can directly set all of them. You can. I already told you, right? If you want to uh, disable your view state, you can directly go to web.config. In that, you need to go to machine.config file, and you can directly give this value enabled view state to false to disable that view state. Okay. So this is how you can disable it. But again, majority of the applications will not allow you to run a load test by disabling a view state. All the stakeholders will ask you to enable the view state and they have to run this load test. The reason is because whatever the time, the highest amount of rendering time or download time, that will be spent only on the view state. This can be one of the performance improvement, but disabling view state will not be accepted by 95% of the customers. Every time you run a test, you need to have this view state enabled and you have to run the test. You don't have any other option. Okay. And these are all the metrics. I'll send you this slide. Okay, these are all the metrics. Whatever the suggested thresholds that are mentioned here, you should have that metric, that value. If any of the value is changing other than this, it means that you have a bottleneck. Okay, and there is no specific direct statement. If you can fix this, you can improve the performance of this particular instance or at this server. We don't have any direct conclusions or direct recommendations. When you have any issue again, you have to go back and you have to investigate all the layers again, like in Java. And tomorrow we'll talk about the connection pool settings, and tomorrow we'll talk about the SQL Server performance tuning. Okay, .NET SQL Server performance tuning. And all of you, please install this .trace. And my request to all of you is please don't share this slide. Okay, this is a COE slide, and you cannot remove this TCS logo here. Please do not share it. There are some practices mentioned here. We also have another one, another E2, which is not really required for you. And there is one other document called .NET. Yeah, it is good if you can take a printout. This will be around. This is not for you actually. This is for the performance actually. This is not. This is for all the .NET developers. If you go back here and if you see all this information, it is around some 300 or 400 pages. So there are so many things here. But tomorrow we'll talk about one of the profiling tool and how we can do profiling and what are all the bottlenecks that we can identify from .NET based applications. And there are 10 bottlenecks from COE and there are some solutions for that. It doesn't mean that not all of you will face the same bottlenecks. Majority of the bottlenecks that you see from the .NET based applications are captured, are recorded, and the same will be shared to all of you tomorrow. Now, you have any questions?
Okay, like today you have covered few part of .NET based application, but probably because I don't have any experience behind, so I couldn't relate much. So if you can spend like 5-10 minutes tomorrow to just give a kind of an overview about how it is different from Java and in .NET.
No,
I
no,
mean, I couldn't picturize anything today.
no. This is a overview. Actually, we are not. I did not complete .NET yet. Tomorrow I'll talk about the total .NET performance issues. Okay, this is a high level overview of how we can investigate, or what are all the different tools that we can use, or what are all the first steps that you need to take. But again, I'll tell you what is that exactly you do in a .NET performance engineering. Not with any of the coding level profiling activities, but definitely with what are all the different things that you need to consider with respect to IAS server tuning, web server tuning, and SQL server tuning. That is the only thing that you can do from your side. You can tune it, or you can optimize from the metrics from both the IAS and SQL server, but from the application side, you cannot do anything.
Okay.
You don't even
So,
understand the basic simple script. Not only you, it can be anyone from performance engineering or an engineering manager, until and unless he has some 3 to 4 years of hands-on experience in .NET coding.
yeah, just wanted to understand, will it be possible, like is there any architectural kind of a difference, if you can, I mean, that is there from Java to .NET infrastructure?
Yes, that is there. If you remember, I have already explained you the JVM architecture, right? And likewise,
Yeah.
we can explain you this architecture, which is this one, CLR. But I don't think so that is really required. If you want, I can explain you that. But
Not in detail, but in like,
at a
if
very high
somebody
level, I
asks,
can tell you. At a
yeah,
very high
and if
level, I can.
somebody asks you that how it is different, because still after the first class also I'm not able to clear out a basic clutter in my mind also, so I'm not able to picturize anything. Probably I need to go through the recording once again today to understand, but to be frank, I am very low in confidence in
No, no.
in .NET.
The problem of performance engineering. I don't call it as a problem, but the area that the scope of a performance engineering is like that. If you see, if you take, if many of the job descriptions, if you take, we need some good performance engineer who has some good experience on Kubernetes. Okay, let's say that Kubernetes. When we talk about engineering perspective, you can monitor all the metrics from the Kubernetes, and you cannot do any of the engineering activities on your own. Again, the Kubernetes developer has to step in, and he has to see what is happening. If you see, the only thing that we are doing here is we are monitoring all the metrics from basic metrics to advanced metrics in all the areas of the infrastructure. We are taking help of some of the profiling tools, and we are trying to identify the performance issues, and we are trying to address all of them to the different teams who are sitting across the project. That is what we are doing. Performance engineering, when we are talking about performance engineering, it is now, it is mainly into Java. That is why the reason we have covered a lot in Java. If you remember, we spoke about all the different bottlenecks or memory areas, profilers. Java, it is into a different direction. But whereas .NET, if someone is asking you, there is an issue with one of the web service, we cannot directly go there. Even today, I don't even have a basic idea on how to install the local environment using Visual Studio. There is some local setup that has been created from one of my friend. I am trying to profile something from that. I'm capturing the data. I'm looking at the data that has been collected from the profiling tool, but I'm not able to understand anything from that. So when we talk about .NET performance engineering, let's do one thing tomorrow, as you said. I will tell you what is the architecture. I already told you, right? If you look at the heap size of .NET, there is a difference. You have 3 generations. One is generation 0, generation 1, and generation 2. That is not the case in Java. And if you look at the garbage collector, there is only one single garbage collector. There is no minor GC, major GC, GC past time. Again, there are different metrics like in Java. We cannot talk all of them in .NET. There is one GC which will take care of all these 3 areas. Very, very simple. But majority of the issues that you see here, I told you, right? High response times, CPU utilization, memory leaks, garbage collection issues, heap issues, and too many web service calls, thread pools. you will see a deadlocks, you will see monitors, you will see locks, and for that you need to use a profiler again. So what I can do for you tomorrow is I can tell you what is that you can do from .NET performance engineering. What is that you do in .NET performance testing and optimization. This is a scratching a surface kind of thing, this session. Tomorrow I'll tell you there is another PPT which will help you with all the metrics. I'll try to highlight the difference between Java and .NET. At least you will understand what makes a big difference between Java and .NET.
Okay. Okay.
Okay.
Okay.
So, but again, do not worry much on .NET. Only 30% of the applications are into .NET now. And even if you see many issues in .NET applications, until and unless if a development architect comes in and asks you what happened, and it is his call to take what he has to do on the next steps. You cannot do anything. You just need to tell what happened in your load test. That's all. You can use some profiler for his additional benefit, but you cannot tune or you cannot improve any performance on a .NET based application. Okay.
Okay.
All right. So we will talk about .NET tomorrow again, and then you
Sharing
can.
this, right?
Yeah,
This
yeah,
PPT.
yeah. But I'll share it, but don't share it with anyone. Okay.
Yes. No.
And don't share this recording too, because it has some client IDs, I guess. I don't know. I mean, there are some names and all. Don't share it. Okay.